Hey everyone, today we'll be going over all the traversals we made in our unbalanced tree, and without any further hesitation, let's get started. And now performing in-order traversal for an unbalanced tree. So in order for us to be able to do so, we are going to be creating a void function called in-order, and then have node be, the root be inserted as a parameter, and then we're going to have if we're at the root, then we will do the following. We are going to call upon our in-order function to get the root on the left. We're going to output the data root key over here, and in order of the root to the right. And then what we will be doing is that we will be outputting our in order traversal, and we're going to be doing count in order traversal of binary tree, and then bt in order of bt root. That should actually be able to get us already set up. Yep. And in fact, let me just clean this part up. There we go. So yes, so we have in order traversal of the binary tree with 5, 10, and 20. That's what we have done. We go to left, top, and then right. Much like in the case of what we did for the balanced tree, except we're just putting this in the unbalanced tree. And now going over pre-order traversal. So pre-order traversal will be the following, much like what we did in the balanced tree, except for we're putting it inside of our unbalanced tree, but the principle still applies. So we do go void pre-order node at the root, and then we will be checking, much like in the case of what we did before and what we did previously, if the root will output the count root key right there, and then we do pre-order with the root on the left, and then the pre-order with the root on the right. And make sure it's already built. Yes, it is. And now we will do the same thing that we did before. We do in order traversal, and then we're going to do pre-order traversal. Let me just clean this up. Pre-order traversal. Pre-order traversal with the following root. Make sure that we have everything already set up in place. And let's run this bad boy. Alright, and I'll just clean this part up. There we go. So yes, it does what is accordingly. So it goes 10, 5, and 20, much like in the case. 10, 5, and 20 in the pre-order fashion. So we already see that is the nature of pre-order. Now let's move over to post-order traversal. And now going over post-order traversal, so what we did, we just left off from our pre-order, and we just moved up all the way to our post-order section inside of our class that we have done thus far for an unbalanced tree. And the way we're going to be writing our post-order is going to be the following, much like in the case of what we did before for the balanced tree, but we're just putting it inside of the unbalanced tree. We go void post-order node root. If we're at the root, then we're going to go post-order root at the left, and then we'll go to the right, and finally output data root key right over here. That's what we do. And now we have our function right here. Let's output the post order. So we're going to do what we did before. It's post order, and bt dot post order. bt root, let's just build this, make sure it's all good, and I'm going to say unbalanced. Just for sake of clarification, they're interchangeable for what we have, because we're not dealing with a binary search tree. There we go, for the sake of simplicity. There we go. Yep, it does so accordingly. So we have 5, 20, and 10. We see in our tree 5, 20, and 10, going by each level accordingly. So we see the nature between all three of the different traversals in an unbalanced tree. Now let's head over and do our breadth first search for an unbalanced tree. Hey everyone, thank you very much for taking time to watch this. If you found this video helpful, be sure and feel free to please like and subscribe. And if you have any other questions or suggestions, please put them in the comment section. And as always, take care. Cheers. Bye-bye.